Hello and welcome to another episode of Lunch and Learn with Vince. I'm Vince Marino, your host, and my guest today is BJ Warren, who is an engineer over at Cornell Pumps. BJ, how you doing?
I'm doing great, Vince. How are you?
Fantastic. What kind of engineer? Tell us what kind of engineer you are and where are you from and how you got to where you are. Tell us a little bit
Yes,
about yourself.
sure. I'm mechanical engineering. I got my degree in mechanical engineering from San Jose State University in California, and not so much practicing a whole lot of engineering now, a little bit, but mostly on the sales side. But we do a lot of applications, and so still utilizing a lot of the a lot of the skills that I learned there. But I grew up in Southern California, down in San Diego, and in high school started kind of doing a lot with my hands, as far as welding and fabrication. So I got really interested in mechanical products, and that's what kind of led me to start into my kind of engineering path, and moved to San Jose to get my degree there in engineering. And San Jose is kind of the tech capital of California there, so a lot of electronics and sensors and things that they teach you about there. And then after school there, I transferred up and moved up to Oregon, and worked with a few different companies for a few years until I stumbled on Cornell about 5 years ago. Started working in our agricultural sales department, where I got to work with a lot of our great farming communities and farming customers, working on customer applications for irrigation, manure pumps. And after that, Cornell started kind of bringing on a program around IoT, and so I took on that role as our IoT Sales Manager for Cornell.
Yeah. Tell me, how did Cornell, a pump manufacturer, get involved in IoT? I'm just kind of curious what that path was, if you will.
Yeah, so it's kind of interesting. Cornell has been around for over 75 years now, and we've always been heavily involved in, we manufacture pumps, and that's what we've done for many years. And Cornell's always been sort of a very innovative type of company. We're always interested in launching new products. We have a lot of pumps, in our product line. And about 4 years ago, our president, Robert Ray, was actually interested in kind of branching out from that a little bit, and getting into something a little bit more on the technical side. We were starting to see IoT, or pump monitoring, is starting to become a thing. And one of the things that that was kind of thought about was we need to get in soon in order to kind of start building this the data behind our pumps. And so that was where it all kind of started. Is we brought in one engineer, and Cornell, we're a bunch of manufacturing engineers, and we have a good sales team and everything, but knew nothing about IoT from the get-go. So we brought in one single engineer to kind of head up the beginnings of the project, and start a new product. And they brought me on once that product was kind of ready to go into the hands of customers. And then today we have almost 20 full-time dedicated folks that work here just strictly for IoT.
Really? Wow. So what markets are asking for monitoring, I guess is the question I should say. What are the industries that primarily have an appetite for this monitoring?
Yeah, so I think all the markets really have an appetite for monitoring. Some are a little more aggressive than others, and kind of come in stages. There's a lot of markets that we cover. We cover the rental market, oil and gas, municipalities, irrigation and agriculture. We do mining and food processing, industrial. So we cover a lot of different markets. And what we've noticed is that some markets are already kind of more involved in the monitoring side of things. And you might see that with like SCADA systems and such, where they already have that involved in municipalities, right? A lot of municipalities have SCADA systems.
Right.
But what we've found is that a lot of the places where maybe SCADA has not been possible, or is maybe just not feasible, is really where we've seen the demand for the IoT side of things and more monitoring, because it's not quite a full-blown SCADA system, right? It's more of a lighter system. It's a little bit more affordable. It's easier to deploy, and so that's where we've seen that kind of more take off.
So I'm going to throw kind of an unplanned, well, all this is unplanned anyway, if you think about it. It's just a casual conversation, but give me an instance, if you can, where, without naming names of companies or organizations, but an instance where there was a problem or a challenge, and with these services that you offer, you were able to charge in and kind of save the day, if you will.
Yeah, so I would say one of the big ones has been the rental industry, and reason being is that there's a vast number of rental pumps that are out there. And these, when I say rental pump, I typically mean either a diesel driven pump. It's got a diesel engine, it's directly coupled to a pump end, and it's mounted on a trailer or a skid. And these are moving around, and they're placed in different areas, and they're used for different applications. And
right.
so,
well, if I may, as an example,
yeah.
I was a couple of years ago, the Mississippi River was just flooding. And I was I think I was in Vicksburg, Mississippi on some business. I actually was passing through from Louisiana. And I stopped in the downtown Vicksburg area, and I saw this skid pump, if you will. You could tell it was there to assist for a reason, and it was strategically placed there. And a municipality person was actually running that pump. I mean, it was
Sure.
some company of a yet to be named company rented these skids out so they could dewater a particular area right by the Mississippi River, or by the city that's on the river.
Exactly. And then was that one for like a flood relief or flood prevention type of situation?
Right. I think the water was so close to the city limits, there was a reason to get that water out of there. It was a couple of years ago, and it was pretty messy, as I recall. I mean, I saw businesses, if you're bordering the Mississippi River, you're up on stilts anyway, but I'm talking about huge multi-million-dollar businesses, but that water was getting up in under those pillars and,
Sure.
encroachment. So I do know about that. But how does the IoT versus traditional SCADA, how does that come into play for
Yeah,
you?
so traditional SCADA is kind of hard to deploy on these rental pumps, right? Because it takes a lot of setup. They're pretty costly, and so it makes sense when you have maybe a pump station, like a municipal pump station, that you have this sort of setup. Then you're making that investment. Maybe you have multiple pumps that are being monitored there.
Right.
But in these rental applications where you have kind of maybe a single one-off pump that gets moved to a different site, whether it's for dewatering purposes like you're talking here, or hurricane relief, or emergency response type of situation, for one, it's difficult to quickly deploy a SCADA system out there. So having some kind of telemetry or monitoring system on that particular pump can be valuable. And the other thing is, in a lot of those applications, especially if it's emergency response, it may not be desirable to have a person on site, at all times to be monitoring what's going on there. And so if you deploy something like IoT on these pumps, it doesn't matter where they go, you can be able to monitor what's going on. A good example of that is, in these emergency type situations, you may not be able to get to these pumps very easily just because of the situations, if it's a hurricane or whatever might be going on. And so being able to see things remotely from kind of a central hub, if you will, and monitor what's going on, things like fuel level can be very important, right? If that pump's been running and it's running out of fuel, okay, that's the most important one we've got to get out to. And so our system basically is being able to track all of that and understand what's going on so that they can dedicate resources where they absolutely are necessary, and not to just kind of stand by and just monitor something long term.
All right, so I've been known to ask all the rookie questions that a traditional person in the pump industry or an engineer might not ask. So I'm going to ask some dumb questions. Actually, there's no such thing as dumb questions.
Not at all.
But, if you're monitoring, let's just use your example. So you were able to deploy a pump that's being monitored via IoT, And I'm assuming beyond fuel, you're also able to monitor things like throughput.
Sure, pressures, flows, yeah.
Right. So let's assume that, for as an example, if something's clogged, let's say an object gets in the way, are you able to discern that? And if so, what do you do?
Yeah, so there's various different ways to monitor that sort of thing. And so typically in our situations, we're commonly monitoring for both pressure and flow, and then also vibration. And so from these different parameters that you're monitoring, you might see all of a sudden your suction pressure, increases, maybe meaning that you have a clog or something's happening there, which can, kind of within these systems, because they're reporting they're reporting over the cellular network, we can pick up on this data. You can actually have the system send a text message or an email or even a phone call alert to an operator and say, hey, we've got a high suction pressure here, and then once they dive into the data, they can actually see, oh, okay, looks like our flows have dropped off, our suction pressure's high, we might have a clog. So it allows them to kind of understand maybe what's going on before they have to send out a tech to actually solve the problem. Because a lot of times maybe there isn't a problem, maybe there's something that they can do remotely. It could be, maybe just the flows have picked up and they need to increase the RPM. And so that's another thing through the system, is not only being able to monitor, but being able to have some level of control, like starting or stopping or controlling the speed. It can be useful.
That's interesting. So that kind of plays right into my scenario where you show a suction issue. You could pause the pump for a minute and start it back up and see if it continues. That's fascinating. I didn't think of that. So I'm just curious. Do you have any visuals that you want to share? Anything that you'd like to give us
Yeah,
an example of?
I can pull up an example of kind of what that might look like here. Let me do that now. So in addition to pressures and flows and engine parameters or motor parameters that we're monitoring, the device that we use is also monitoring vibration. So we're actually mounting the device directly to the bearing frame of the pump, and so we can pick up on both axial and radial vibration. So what we're looking at here is a chart of axial and radial vibration. You can see, and we have kind of, what we're looking at is sort of a trend line, right? So these lower values here are sort of where that pump is typically operating. And what we're noticing is we have these high spikes that occur, every few hours. And so this is a good example, rental situation. You have a pump that's out there doing some kind of task. A lot of times these pumps are just started and then they walk away from them because they maybe need to go tend to another pump or another situation. So they've got this pump running. And the question is, well, what exactly is going on here? And so first of all, these high vibration spikes, are alerted with a text message or something letting the customer know, hey, we've got some high vibration. So if they pop into the data, they can see, okay, well, we're getting these spikes, every few hours, and they're kind of, we're seeing a pattern here, right?
Yeah.
And so a lot of systems, when you're just looking at vibration, this is important and it's good to know, and it's telling us there's something going on, but what is it exactly? And so if we take a look even further, we can kind of go to the next screen here. And this is where we are looking at the different pressures. And so as you can see kind of down below, it's a little bit hard to tell just because it's a slight discrepancy in what we're looking at. But this blue trending line down here is our suction pressure. And so what you're seeing is suction pressure kind of, it's a little bit bumpy, but we're getting this low value that's every so often. And that actually correlates to where those high vibrations were. And so it's a good example where the IoT is letting you know that there's a problem. It's probably related to suction pressure, but what exactly is causing this? And so with a quick phone call, or maybe now going out on site and seeing what's going on, this particular pump was in a dewatering situation and it was running. And as that water level would start to go down, it was bringing it into a safe level. Well, it was also sending that pump into cavitation. It could no longer perform that suction lift anymore. And so now that pump is either running dry or cavitating, which is causing those high spikes. And then, more water would come in, it would go up into a happy level, we'd be at a normal vibration, and then it would occur again. So we're kind of seeing this surge, if you will, of the water level kind of rising and lowering. And these things can be fixed, right? So in this particular case, putting a float in the water to maybe turn the pump on or turn the pump off, or a level transducer to change the speed. So as that water level goes down, maybe the speed also drops down, so it can kind of maintain that and also run without cavitation.
Interesting, almost like riding the gain or adjusting accordingly to the
Adjusting to the
level.
demand, right?
Right,
Exactly.
right. Interesting stuff. That's fascinating. So I'm curious, are there other types of monitoring services that you offer? I mean, is it one example fits all scenarios, or are there different types, if you will, different grades or levels?
There's definitely different grades or levels. And it comes down to a couple different things. What is the customer looking to do? And so that's a lot of what we try to involve ourselves in, is not just here's a one size fits all solution to a problem. It's what is your problem, and let's try to tailor a product or service around that problem so that we can resolve it in the most economical and the way that makes the most sense. So we have various different pieces of hardware that we deploy in different situations. One of them is our pulse. And the pulse is essentially a simple small device that a user can put on a pump, and it's not remote monitoring, but it's a way to gauge, what is my vibration and temperature of my bearing frame or any part of the pump at a particular point in time. So it's not tracking trending, it's not tracking anything over, the length of time, but it's capturing a snapshot. And so if you're doing an initial install for a pump, and this pump is going to go in service in an agricultural type situation for many years, it might be wise to check the vibration right out of the gate and see where you're at. Maybe there's a problem, maybe there's not, but it's still a good idea to kind of baseline where things stand today. And then maybe every month going out there and when you're going to be maybe servicing or pumping some grease into it, you're also taking a vibration measurement. And this is creating a log. And this is all done over Bluetooth. You just scan it with your phone and it takes a reading. And so what that allows the customers to do is just kind of baseline the pump. And as things start to change, or as things start to wear out, maybe, wear ring or impellers getting out of balance, they might see those changes start to, to take effect, which then leads them to say, okay, maybe it's time now we need to do a pump rebuild, or we need to pull things apart to see what we have going on here. Maybe we need to look inside the suction pipe and make sure there's nothing lodged in there. So that's a simple way. It's kind of the most economical way to get started in IoT and just kind of the basics of it. And then beyond that, we use our product called the Copilot, which is more of a robust system in terms of it can remote monitor. So it's communicating over the cellular network, but it also has additional inputs that can be brought in. So at a base level, you're monitoring vibration and temperature, and you're tracking that over time. But you have inputs where you could bring in pressure transducers or flow meters or level sensors or temperature probes or additional vibration sensors. So it really is limitless. It's limited by the number of inputs you can take in, but we can kind of tailor what sensor products to put with the product around that specific application, to where, maybe each application, customers are interested in different things, right? If you're up in a really cold environment, temperature might be really critical, because if that water temperature drops, you might have freezing, which can cause damage. So that might be important for one person, while somewhere else where they're maybe filling a tank, monitoring that level in that tank is absolutely critical, because they can't overflow it, or they want to make sure it stays within a certain level. So we try to kind of take in what it is that's important to them and then package a product system around it.
I got a short story. I was at a wastewater municipality type plant, rural Alabama, and it was adjacent to some kind of a factory of some kind. Now, I only say that because when when the plant was discharging, and I believe it was hot and soapy water,
Hmm.
like at 2 a.m., copious amounts of this water. And it would come through the sewage system, and it would throw off their pumps. They had no idea this was happening. I mean, this is
Sure.
back in the day when you just had a clipboard. You know what I'm saying?
Right.
And
Right.
I had no idea that the temperature, if it's boiling soapy water from, and I don't know, I think it might have been like a high tallow plant or some massive facility that just did a flush every night at like 2 a.m.
For
And
sure.
these guys had to like reverse engineer what the heck was going on to figure out,
Right.
you had to, I mean, you probably have many success stories where you've charged in and saved a day like that. Have you got another one?
Yeah, those are kind of interesting ones because it's like everything might be fine and dandy when there's people standing around, but as soon as you walk away, and these things are designed to run for hours and hours, or maybe continues 24/7, but one little thing in the process can set something off, right? And if you're
Right,
not there at that moment in time, you'll never know that it's even happening.
right.
We were at a mining facility. It was a sand and gravel plant, and they have a big tank where they've got several pumps around the perimeter of the tank that are moving fresh water throughout the plant. And it just so happens, and this was a good example because we were talking to this customer about Copilot and about vibration monitoring. And it's not very often that anybody goes out to these pumps to kind of see what's going on.
Right.
And so we were standing there, we were talking about vibration monitoring, and we were talking for about 5 minutes. And all of a sudden, the pump that we were standing at just started cavitating like crazy. And then the next pump started cavitating, and then the next pump. So it kind of made its way around the circumference of the tank to where 5 or 10 pumps were now cavitating, and then it stopped. So it happened for just 5 or 7 minutes, and then it stopped. And so because we were standing there and we just happened to be there at the right time, to catch that. But otherwise, this plan has been running for months, and nobody ever knew this was occurring. But after another hour or so, that whole process happened again. So then it
Really?
was up to them to kind of decide, okay, what's causing this. So they started looking into the water levels and things in the tank, into maybe the valves and what might be causing it. But it's a good example to where if you have this system, a system that's monitoring vibration or the various parameters on a continuous basis, those are things you're going to pick up in the data. And then you're going to see right away, because they may not seem like much, but if you're cavitating every hour,
Oh,
that can cause some serious damage down the road, or life to the pump is going to decrease.
oh no, it's a danger too. I mean, eventually,
Sure.
if it's going unchecked, yeah. I mean, so what was the cause of this cavitation? I mean, what?
So they had some valves that were opening and closing at kind of improper times, is what it came down to. Um, but so yeah, it's kind of, it's always interesting to, not at all, you don't get always so lucky to be at the right place at the right time to catch these things.
That's
And so
right.
that's where this system, really comes into play, or systems like this that, can monitor, over time. Um, but another good example was an agricultural situation where we had, these were diesel driven pumps. They're out on a big area, several acres, where they're doing some irrigation. And because of the nature of the irrigation down there in California, sometimes they're moving pumps around from place to place, right? You might be irrigating one field, and then you're taking that pump, moving it to another field and irrigating over here. So the setup around the pump is not always ideal, right? They're using jack stands or whatever they could find to kind of hold piping and things like that. And most of the irrigation happens in the evening when it's cool and the sun's not out. And so this particular case, they were using our system to monitor vibration, and it would always happen. Every few nights, somebody would get a text message alert, and they typically have a couple farmhands around that are helping to manage what's going on, but there's not somebody at every single pump. And
Yeah.
so they'd get a text message saying, hey, we've got high vibration on pump XYZ. And so they'd head out there, and sure enough, there'd be something going on, right? Leaves or debris maybe clogging the impeller. Or we had one instance where the suction support had collapsed, and it was some wood that they had kind of piled up to hold up the suction side, and it had collapsed. and it was actually starting, the piping was starting to drag the pump down an embankment. So,
Wow.
if those things kind of go untouched, or, they go unnoticed, they can really cause some harm. So that's where our system actually saved them quite a bit in pump repairs, just by kind of catching these problems before they turned into something a lot worse.
Yeah, and the solution may be just to shore up the supports or whatever, but knowing that you have the problem is 90% of the issue, I suppose. No, 90% of the way to solve it. So fantastic. So where is IoT and Cornell headed for the future? I know you can't talk about too many things, but if you can give us an idea of where we're headed, that you
Yeah.
are allowed to talk about, that would be great.
No, for sure. Yeah, Cornell is, we're headed in an interesting direction. One of the things that we're focused on is, various applications. And what we've noticed with IoT is that there's so many applications where it can be employed. It's not just around pumps, it's not just around rotating equipment, but it's around really any equipment that might have something that you want to monitor on a
Yep.
regular basis. And so we're actually moving down the path of being able to monitor other types of equipment, like a generator, let's say, where you have a diesel generator that's moving around, a light tower, let's say, or compressors. So there's a lot of different types of systems that are out there, similar to pumps, where we can capture some of that information, and then also give that back to the customer so they can see what's going on. And where we see that kind of being a fit is, you have if, let's say, this, a lot of companies who have maybe rental fleets of different types of products. I think it's important for them to be able to rely on one system that can do, what they need for all their different products. And I think what we see out there with IoT today is that it's very kind of spread out, right? You've got a product for this and a product for that, and it's kind of all over the place. And at the end of the day, I think what sometimes people get frustrated with is that they have all these different platforms that they're using, to try to monitor their equipment, and they would really just like one solution for everything. But it's difficult, right? It's difficult to find a product that really can kind of, that's not a one size fits all, that's not just doing a couple things. It's something that can be really tailored to each individual application. And so we're kind of focused on trying to have a variety of different IoT products that can fit into, our portfolio. And that, in addition to the sensor products that are out there, level sensors and flow meters and pressure transducers and such, so that when a customer buys a package from us, they're having to do as little work as possible to get that, deployed on whatever piece of equipment that they want. We don't want you spending thousands of dollars or many hours to get something installed. We want it to be quick, easy. And so that's why, by having sort of our own sensors and our own wiring harnesses, everything's labeled, it's color coded, it's just plug and play. They're not having to figure out how to strip wires and solder things together. It just kind of it alleviates a lot of that headache.
Nice. Well, unless you have some other visual aids that you want to show, I don't know. Let me just ask you, do you have anything else to share as far as visual talking points or?
Sure, I'll show you kind of what I was talking about there with the plug and play nature of our product. I'll share my screen real quick with you.
Absolutely. Everybody loves plug and play, that's for sure. I mean, if you think about it, it's just so much more. There you go. Oh, yeah. Oh, that's the co-pilot right there.
So that's our co-pilot there. You can see we've got a couple of M12 connectors that are on the bottom. And then we've developed these kind of pigtail harnesses that come off of that, and they can easily be installed or disconnected. And then off these pigtails, you have a variety of little Deutsch connectors. And so you can plug in a flow meter or plug in a pressure transducer. And like I was saying, they're labeled, they're color coded. They make it just kind of easy. So if somebody wants to kind of expand their system, maybe they start out with just the co-pilot, and then they can expand and say, okay, I want to add a couple pressure transducers. They can do that. We can tap into the engine controller modules. We can tap into VFDs, and that way we can just extract more and more data, for the particular application.
Beautiful.
Um,
Let me ask you this. I mean, this might be kind of I might end up getting a no here, but I'm just curious. If you discover a client that has some challenges and they already have some things in place that are not related to the Copilot, can you integrate? Is there any capability to integrate with some existing
yeah,
equipment?
so sometimes we can, and it really depends on the type of equipment that they have. A lot of customers will come to us and say, well, I already have a flow meter. I don't necessarily need to or want to buy and invest in another flow meter. And so we work a lot with customers on kind of trying to utilize existing equipment if they do have already, in their possession. So flow meters are a good example. There might already be one installed in the piping that they're using, and they're just monitoring maybe just the the display that's on the flow meter. And so a lot of times we can tap into that flow meter and gather that data and report out on it. Same thing with VFDs or PLC systems is, we might be able to, depending on, which VFD it is and, what's available to us. We commonly are tapping into, existing equipment that's there with the customer. And that really, it can be a challenge sometimes, especially if it's something new that we haven't seen before. So there can be a little bit of work involved. But I think that plays into, making sure that we have a team of folks here at Cornell that are there to support and there to kind of understand and take in the manuals or Modbus maps and all that data, kind of digest it and say, okay, well, this is what we can do, with the equipment that you have there on site.
All right, I got you. That's very interesting. So tell me a little bit more about Cornell. What's their service area? How far will you go to resolve issues for customers?
So we primarily are focused on North America. So Cornell's, primary markets are in United States. We do a lot of work in Canada and Mexico, but we're international. So we cover majority of companies around the world, and in terms of pumps. And with our IoT, we are primarily in North America as well, but we also have several products that are operating, in Europe or in South America and other parts of the world, Australia. And so one of the ways we do that is, cellular connection is a little bit interesting when you start getting international, because you're dealing with various different telecom providers. So we've tried to simplify all of that. We use a global SIM card that can operate on various different networks around the world, to try to just make that process as simple as possible. So you're not having to take the device and walk into your cellular store and say, okay, I need to get a data plan for this. We cover all of that as part of the system.
Absolutely. I'm very familiar with the challenges of data and SIM cards and all that. So yeah. Well, this has been delightful. I've learned a lot. I hope my viewers have too. And just want to thank you for taking the time to chat with me a little bit.
Of course.
And
yeah, it's been a pleasure.
if there's a chance for us to do this again as new products start to deploy, please give me a shout. I'd love to do this again with you and get an
Yes,
update.
most definitely. Yeah, we'd love to.
So I want to thank you, and I want to thank the viewers. I want to just say, if you like this video, I want you to do me a favor and hit subscribe, hit the thumbs up, like it, forward it out to your friends and neighbors, and share it. But more importantly, if you're interested in hearing more, reach out to BJ Warren over at Cornell Pumps. You never know. Anyway, this is Vince, Lunch and Learn with Vince, and BJ, I can't thank you enough. Let's do this again sometime.
Thank you, Vince. I appreciate it.